We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
I am going to teach the new concept of operating system. It's a deadlock. I will also explain what is deadlock, classification of deadlock, and what is banker's algorithm. Then, what is deadlock? So, first of all, the deadlock can occur on the shareable resource such as file, printers, database, disk, memory, CPU, etc. So, what is deadlock? The deadlock is the one process is waiting for the resource R1 and which resource is already held by the another process. In the diagram, the P1 process is waiting for resource R1 and R1 is already held by the another process P2. So, in this situation, the deadlock can be generated. Then the types of resource. The first type is reusable resource and second one is consumable resource. What is a reusable resource? So it is a used by only one process at a time, and it's an example of the reusable resource are the processor, IO devices, files, database, primary memory, secondary memory. Those are the reusable resource. And next concept is what is a consumable resource. The consumable resource is one that can be created and destroyed. The message is a example of the consumable resource. So next point is process utilize the resource in the following sequence. The first step is request for the resource, second one is use of the resource, and third one is after using the resource the process is release it. So these 3 steps are the process utilize the resource based on these following steps. So next concept is RAG. RAG means resource allocation graph. In the process and the resource are represented by the node in the directed graph. Then graph the consists of the set of vertex and edges like same wise in the RAG it consists of set of process and set of resources. The process is graphically represented by circle and the resource is graphical represented by rectangle. So my next point is if P gives R, so it is indicate that the P request for the resource R and it is also called request age. And next point is if R gives P, it means resource R is held by the resource P and it is also called the claim age. The next point is the circular wait with the deadlock. And in the diagram, there are main 2 processes and 2 resources P1, P2 and R1, R2. P1 gives R1, it means P1 sent the request for resource R1 and R1 is already held by the P2. P2 is sent the request for R2 and R2 is already held by the P1. So it is generated the circular wait. And if the circular wait can be generated, then the deadlock is also generated in that system. Okay, and my next point is circular wait but no deadlock. So this diagram is as above, but in there are in some same way the same 2 processes and 2 resources P1, P2 and R1, R2. But R1 consists main 4 R1 consists 4 instances and R2 consists 2 instances. In the R1 for instances, the P1 is sent the request for particular instance of R1 and another instance is held by the P2. So there is a circular wait can be generated, but there is no deadlock in the system. So it is a circular wait but no deadlock. So it is a circular wait but no deadlock. Okay, so main basic concept of the deadlock is the process is the process request for the resource and which resource is already held by the another process. So this type of if situation can be generated, then so in the circular wait, if circular wait is generated in the cycle, if the loop can be generated, then it is the deadlock can be generated in the system. Next concept is deadlock characteristics or deadlock prevention. Both are the same concept. So in the deadlock prevention, the main four concept in the deadlock prevention, there are the main four concept. First one is mutual exclusion, second one is hold and wait, third one is no preemption, and fourth one is circular wait. So let us start with first point, mutual exclusion. A resource may be used by the only one process at a time. It is called mutual exclusion. No another process can use a resource while it allocates to any other process. So at a one time, only one process can use a resource in the mutual exclusion. Second concept is a hold and wait. Hold and wait means a process that is holding at least one resource and is waiting for the another additional resource which is already held by the another process. So it is called hold and wait. Next concept is no preemption. No preemption means once a process has obtained a resource and the system cannot remove the resource from the current process until the process has process has finished using the resource. A process has completed its execution. So it is called no preemption. And fourth concept is circular wait. Circular wait means the circular chain of hold and wait condition in the system. It is called circular wait. So these four are the concept of deadlock prevention. So it is a possibility of the deadlock. It shows the possibility of the deadlock prevention or a deadlock characteristics. So next concept is deadlock solution, and main basic four concept of the deadlock solution is deadlock prevention, which I have already taught, and the second one is deadlock avoidance, deadlock detection, and deadlock recovery. So deadlock, what is a deadlock prevention? Deadlock prevention is to condition a system to remove any possibility of the deadlock occurring or a deadlock possibility. Okay, so it is called deadlock prevention. Deadlock avoidance means deadlock can be avoided by the identify the safe state or a unsafe state, and we can find out the safe state and unsafe state by using the Banker's algorithm. I will explain what is Banker's algorithm. Okay, it is useful for deadlock avoidance. Deadlock detection. Deadlock detection method are used in the system in which deadlock can occur and which resource and which processes are used in the deadlock in the deadlock of the system. So we can find out, we can detect the process and resource. So deadlock recovery. Deadlock recovery means used to resolve the deadlock from the system. Okay, and then we can also some basic by using basic concept we can recover the deadlock from the system. So this main four concept of the deadlock solution it's a prevention, avoidance, detection, and the recovery. Detection. Deadlock detection is the process of determining that the deadlock exists and identify the process and resources involved in the deadlock. So this concept is a deadlock detection. We can also detect the process and resource which is involved in the deadlock. So for the deadlock detection, it is in the deadlock detection concept, wait for graph we can use. First, I have already taught resource allocation graph. So wait for graph is totally depend on RAG. So in the RAG, the main basic instance is resource and process, and in the wait for graph it is only indicated by only the processes. So we can find out the wait for graph. It is based on the resource allocation graph. So the first point of the deadlock detection is wait for graph is a graph where each node represent a process. So next point is PI gives PJ. It means that the PI is blocked and waiting for the process PJ to release a resource. So it is also called PI gives PJ. Next point is the wait for graph for of a system is always a smaller than the resource allocation graph of that same system. So wait for graph is a smaller than RAG and is totally depend on the RAG. There is a deadlock in the system if and only if there is a loop in the wait for graph of that system. So deadlock detection involve main two issues. First one is maintenance and second one is searching. Searching the process and resource which is involved in the cycle, which is involved in the deadlock, it is a very difficult task. So it is a issue of deadlock detection. So it is a second concept, deadlock detection. Then my third concept is deadlock recovery. So how to recover the deadlock from the system? There are some basic steps to recover the deadlock from the system. First step is it is not step but it is a concept. So there are main four concepts. First one is process termination. Then process termination, the deadlock is removed by aborting a process. All the deadlock processes are aborted. We can select the process and which is involved in the deadlock, so we can abort this process from the system. So it is also recover the deadlock from the system. So then second one is resource preemption. Resource preemption means a resource temporarily take away from the current process and the system is allocate the resource to the another process. So it is called resource preemption. Then the main basic issue is the selection of the resource for the resource preemption. So priority we can first point is for selection of the process. Priority of the process. Higher priority process are not selected. It means if any process has higher priority, then we cannot select the process for resource preemption. And second point is process which is close to completion are not selected. If any process is very close to execute complete or close to complete its task, so we cannot select this type of process for the resource preemption. Third one is recovery through the rollback. Recovery through the rollback in this concept, When the process in a system terminates, the system perform a rollback by undoing every operation. We can use the checkpoint, and the checkpoint is a process. It means checkpointing a process, it means that its state is returned to a file so that it can be restart the later it can the system can restart at the point of after the at the point of checkpoint. So it is if we use checkpoint, if we use if we do the commit operation, then we can roll back the system up to the checkpoint. So we can recover the deadlock up to the checkpoint. So we can recover the deadlock in the system. And the last point of the deadlock recovery is a starvation. So process waits for an event that might never occur in the system. So the select victim only for the finite number of time. Use rollback method for selecting the victim process. Okay, so starvation is also the resource recovery. So there are main basic four concepts. One is resource preemption, third one is resource through the rollback, and last one is starvation. Concept is a deadlock avoidance. We can avoid the deadlock by finding the safe state or unsafe state by using the banker's algorithm. So deadlock avoidance, the system must be able to decide whether granting a resource is safe or unsafe. So based on this algorithm, banker's algorithm, we can find out the safe state and unsafe state. So in the banker's algorithm, then if the deadlock state is also called the safe state, deadlock state is also called the unsafe state. The safe state is not a deadlock state. Okay, so in the banker's algorithm, main four concepts are using in the deadlock avoidance. First one is allocation, second one is max, third one is need, and fourth one is available value. So based on these four values, we can find out the safe state on or unsafe state based on banking algorithm. So what is the allocation value? Allocation value is a table. Allocation is a table in which the row represent as a process and column represent as a resource. So if we can write the alloc ij, so I means process and j means number of resources. Second concept is a max. Max means maximum number of resources that process require during its execution. So this is a max value. Third concept is a need. Need means if we want to find out the need value of the matrix of the table of the resource and process of the system, then we can apply this equation. So we can max minus allocation, we can find out the need value of all the process. So and last one is available. Then if we want to find out the available value, then number of the resource, the total number of resource minus the sum of the allocation to all the process. After this based on this equation, we can find out the available resource. So this basic four concept: allocation, max, need, and last one is available. So based on these four concept, we can find out the deadlock. We can find out the safe or unsafe state by using the banker's algorithm. So we can start the deadlock avoidance with the banker's algorithm with example. So in the example, in the question, there are main 5 processes P1, P2, P3 up to P5, allocation value, max value, and available value of each and every process. Okay, each and allocation value of the resource for particular process, max value of the resource for that particular process, and available value for the available value of the resource. So if we apply the banker's algorithm on the system, we perform the following steps. The step number one is we can find out the need matrix. So need, it is equal to max minus allocation. If we want to find out the need matrix, then we apply this equation. By applying this equation, we can find out the need matrix of the system. So after the step number one, we can apply the step number two. So in the step number two, we can apply this condition. So if we need and available, if need is less than or equal to available, if this condition is true, then we apply the new this equation. We can find out the new available value. So new available equal to available plus allocation. So if our condition is true, if less than or equal to, if it is true, then we find out the new available value of for the particular process. If the condition is false, if the condition is false, then we do not execute this process for further any steps. Okay, so so we start with the step number one. We can find out the need matrix of the each and every process. So need is equal to max minus allocation. So for P1 process, max minus allocation means max minus allocation for P1 process is 7 minus 0, 5 minus 1, then 3 minus 0. So max minus allocation, we can find out the need matrix of P1. So next for P2, 3 minus 2, 2 minus 0 and 2 minus 0. So we can find out the need matrix. And up to same likewise, we apply this equation max minus allocation, we find out the need matrix for all process. Okay, so here this is a need matrix for P0, P1, P2, P3 or for P4. Okay, so apply the step number one, we can find out, we can further go forward to the step number two. So in the step number 2, we can check the condition, it is true or false. So for step number 2, the first step number 2, it is apply for the P0 process. So need matrix of the P0 is 743 and available value of the P0 is 332. So in this situation, the need is greater than available, so condition is false, so we do not execute the P0 process further. So we come forward to the next process, P1. So P1, the need value of the P1 is 112, available value P1 available value is 332. So it is a true, need is less than or equal to available, so we the condition is true, so we find out the new available value. So new available equal to available plus allocation. Available, the value of available is equal to 332, so here we put the 332 plus allocation value of the P1, so here we put the 200. So after this equation, we can find out the new available value of P1 process. So next, P2 need value of the P2 is 600, available value is a 532, so it is a false, so we do not execute the P2 process. Then for P3, the need value of the P3 is 011, available of the P3 is 532. So here it is a true, so we find out the new available value. After applying this equation, available plus allocation, we find out the new available value. So this new available, so 743 is available value for the next process. So P4, need and available. So need of the P4 process is 431 and available value is, we can find out the new available value 743. So it is a new available value for the P4. So it is condition true. So we find out the new available value, available plus allocation. After apply this equation, we find out the new available value. So it is available for the next process. Here I have completed the first round P0 up to P4 process. So we can start the second round, but we apply this condition on these processes which have the condition which condition have a false. So here P0, the condition for the P0 condition is false, for the P2 condition is false. So in the second round we apply this equation on the P0 and P2 process. So let us start with the second round. So in the second round we apply this condition for the P0. Now need of the P0 is 743 and new available value for the P0 is a 745. So condition is true, so we apply so you can find out the new available value based on this condition 755. So this available value is a next for the the 755 is a available value for the next process. So we can apply this condition also for P2. So need and available, need 600 and available 755. So it a condition true, so we can find out new available value, available plus allocation. So 755 plus 302, the value is 1057. So now it is a new available value. So we can find out the save state, all the save state, and at last we can find out the save sequence. So my save sequence is a P1, P3, P4, P0 and P2. It means if we this sequence up to P1, P3, P4, P0, P2 likewise, then the system. So we